And we'll start with section 5.4. Section 5.4 is called a general approach to factoring. Now, I would like to review a little bit with what we learned in the last class, because factoring is the most important thing you'll learn in math. And I want to really reinforce that for this section, and I'll give you examples from each type that we went over. So just as a review, when we factor, we talked about there being 4 different types of factoring. One type is called greatest common factor. Or GCF. Another type is called grouping. We also have trinomials, and then special cases. We talked about 4 different types of special cases. The first type was a difference of perfect squares. We said the formula was A plus B times A minus B. We also talked about the sum of perfect cubes. And the formula was same sign, opposite, always positive. You have to have these memorized. Instead of writing the other equation, I'm just going to change some of the signs. So we also had a difference of perfect cubes. So we would just, if that was a minus sign, this would be the same sign, this would be the opposite sign, and then that last plus would always be positive. So we really wrote 2 formulas just by changing a couple of signs. And towards the end in class, we talked about another special type of factoring. I told you it wasn't really necessary that you know, but we went through a couple examples like that. I'm going to put it here. And again, I'm not going to say that it's mandatory to know this, but it is an extra formula just for your notes to be complete. So let's say we had a squared minus 2ab plus b squared. And we'll take a look at examples like this. This would factor to be a plus b squared. We also talked about if you had a squared plus 2ab plus b squared. This would be, let's just make this negative and this will be plus. We said if these are perfect squares and the middle term looks like it's 2 times a combination of these, then we could factor like that. So we'll go over examples just to make sure that that we're good with this. All right. So the directions are just going to be factor. Well, first thing we'll do is we'll start with GCF factoring. We'll just go through some examples of those. What if we had 10t plus 150? Ty, I put your old test on your notes, okay? You're welcome. So we want to see what's the biggest number that we could divide 10t by and 150 by. And the biggest number would be 10. So if we divide both of these by 10, this would factor to be whatever that quotient is, which would just be t plus 15. And then we have a 10 in front. That would be completely factored. We also want to look at each factor, like 10, can you factor that anymore? No. T plus 15 doesn't factor anymore. Everything's factored as much as it can be. Try something else. How about 2x to the third plus 10x squared minus 4x. We could take out a 2x from everything. And then what we do is we write the GCF and then we write the quotient, which would just be x plus 5x, or let me see, x squared plus 5x minus 2. How about something like this? I'll give you one a little bit tricky. What if we had 12m times p minus q minus 7n times p minus q? What's the greatest common factor? What's in common between those two terms? Yeah, both have a p minus q, so let's divide by the p minus q. And again, we write the GCF, and then we write what's left over. Do one more. Move on to something else. X minus 2 times 3x plus 1 minus x minus 2 times 2x plus 7. So the GCF here is x minus 2. So the rule is we divide everything by the GCF. And what we're left with is the GCF. And then we have 3x plus 1 minus this whole thing. So you want to make sure that you put that whole thing in parentheses. Yeah, so we have to distribute the negative. So this would just be x minus 2 times 3x plus 1 minus 2x minus 7, or x minus 2 times x minus 6. That would be it. All right, so that's those are some examples of GCF factoring. I wanted to go through some binomial factors. And remember, binomial just means two terms. So some examples of binomial factoring would be, I'll just check something. Like if we had 36x squared minus y squared. Generally, if you have two terms, that's a special case. So you have to think, all right, what squared is 36x squared and what squared is y squared? Well, 6x squared is 36x squared and y squared is y squared. So according to the formula, once you have something squared minus something squared, we just say a plus b times a minus b. This would be 6x plus y times 6x minus y. What about if we had 8x to the third plus 1? So this is the same thing as 2x to the third plus 1 to the third. And the formula for a cubed plus b cubed would be a, same sign, b, times a squared opposite sign, always positive, b squared, like that. So this would just be 2x plus 1 times, this is 2x to the second power minus 2x times 1 plus 1 squared. Or just fully simplified, 2x plus 1 times 4x squared minus 2x plus 1. Let's see. What if we had something like this? About 4x. Let me see here. 16 x to the second minus 1. What we want to do is we want to write this 4x to the second power minus 1 to the second power, or just 4x plus 1 times 4x minus 1. That would be how we factor our binomial. All right, let's talk about how to factor a trinomial now. If you remember when we were talking about trinomial factoring, we did the x, where we had the b term here, ac here, and we were looking for numbers that added together were the b term and multiplied together were ac. So with a trinomial, let's say we had a problem like this. What if we had 16m to the second plus, oh, I don't like this one. That's okay. 16m to the second plus 56m plus 49. One thing that we could do is we could do 16 times 49, but we also talked about another type of factoring that we could do here. If you notice, 16m squared is the same thing as just 4m to the second. 49 is 7 to the second. And 56 is 2 times 4m times 7. We talked about this as the optional special case that you guys don't really have to remember. You could have done this using that AC factoring technique we talked about. But if you could recognize that, it's a little bit easier. And we just say this is 4m plus 7 to the second. Like I said, you could have also done this using the x technique, and you would have got 4m plus 7 times 4m plus 7. What about 8x to the second minus 13x plus 5? This would be a good example where the first and the last numbers aren't perfect squares. So we could use the x technique. 8 times 5 is 40. Numbers that multiply to be 40 and add up to be negative 13 would be what? Ooh, that's a good one. Negative 8 and negative 5. Very good. So from here, we would say 8x squared minus 8x minus 5x plus 5. If you cut it down the middle, you could take out an 8x and you get x minus 1. You could take out a negative 5 and you get x minus 1. So factored, you would get the GCF times 8x minus 5. All right, we'll try one more. This is a really good problem. I can't tell you that it's on the test because that would give you an unfair advantage, but I can tell you that it's a really good problem to study for the midterm. So what if it was 12x squared minus 25xy minus 7y squared? Something like this. It is a trinomial and it looks a little different than the other trinomials that we do, but just follow the rules. The rules are multiply 7 times 12. 7 times 12 is 84. We're looking for numbers that multiply to be negative 84, and they have to add up to be negative 25. So can you guys take a minute and see if you could figure out what numbers do that? So the easiest way to do it is what goes into 84. And if you guys get it before I do, just let me know. I'm going to start with 2, maybe 6 and 14. They give me 25, so that's no good. 28 and negative 3. Let's see, those do add up to be, well, they have to add up to be negative 25, so maybe negative 28 and positive 3. Did that work? That does work. Very good. Thank you. Who did that? Is that Chris? Nick? Oh, who said that? Evan, did you do that? Oh, okay. All right. All right. All right. That's great. So we got negative 28 and 3. Thank you for the help there. Negative, and you can see that's the hardest part. Once we get those two numbers, everything else is super easy. So even though this has y's in it and x's, it doesn't matter. All of these problems we solve exactly the same way. If it's a trinomial, we break up the middle term. just like this. So just like before, we broke up the middle term. We're going to cut it down the middle and factor by grouping. Looks like we could take a 4x out of this first group, and we get 3x minus 7y. We could take a y out of the second group, 3x minus 7y, and we get 3x minus 7y times 4x plus y. Okay. Just to finish up, I want to show you a grouping problem. Let's see here. I'll call this part D. And we're going to do grouping with more than 3 terms. So what if we had, we'll just do one example of this. What if we had p to the third minus 2pq squared plus p squared q minus 2q to the third. And again, I might sound like a broken record, but that's by intention. If you have 4 terms, we factor by grouping. Cut it down the middle, take out the GCF of each half. If you have 3 terms, you do that AC method with the x. So this has 4 terms. Looks like we could take out a p, and we're left with p squared minus 2q squared. The second group, it looks like we could take out a q. We're left with p squared minus 2q squared. And just following through with the steps that we have been doing, p minus 2q squared times p plus q. That would be our answer.